Hello and welcome to our third and final installment on sections 2 and 3 for DMA 10, adding and subtracting integers. So far in these sections we've covered the double sign rules, our rules for combining integers. We practiced with some small integers and then some large integers, and then looked at some combined operations. This time we're going to cover some applications from the book and some word problems from these sections. This first application comes from your textbook. It's called the Colored Tiles model. In this model, blue tiles are going to represent a positive integer, positive 1, and red tiles are going to represent a negative 1. And you'll see these a lot in your homework and in WebAssign. You might have to solve problems like this. So for this example, we're going to write a number sentence and solve for this picture below. So here first we have let's see, 1, 2, 3, 4 positive blocks. We might represent that with a positive 4, and then we have, let's see, 1, 2, 3, 4, 5, 6 negative blocks. So we might write that as 4 minus 6. That would be a good number sentence. Now we can solve this using our rules, but we can also think of these positive and negatives canceling each other out. So here we have a pair of a positive 1 and a negative 1. Those are going to add to 0 and cancel. Here's another pair, positive 1 minus 1 is 0, positive 1 minus 1 is 0, and then our last pair. So after we've canceled everything out, what's left? Well, we have 2 negative squares left, so the answer to this problem would be negative 2. The heaps and holes model is another method that the book uses to kind of visualize adding and subtracting integers. Here, a heap or something underground, like these over or above ground, are going to represent a positive 1. Okay, and a hole, something underground, is going to represent a negative 1. So we're going to write a number sentence for this picture here, and then solve it as well. So first we have a negative 3. So there's 1, 2, 3 holes in the ground. So we would write that as negative 3. And then we have 4 heaps, or plus positive 4. Okay. We could solve that using our integer rules, but the way that the book likes to think of it is that each heap is going to fill in a hole. So this heap here would fill in this hole right here, and they would cancel out to 0. Positive 1 and negative 1 would be 0. Again, with this pair of heap and a hole, and with this pair here. So each of those heaps fill in each of those holes. After we've paired everything up, what are we left with? Well, we're left with 1 heap, or a positive 1. Now on to word problems. This is an example of a financial balance sheet, and you'll see a lot of these when you're working in your homework. All the numbers in parentheses, like the special programs here and maintenance here, are going to represent negative numbers, okay, or debts. And then the assets are going to be written without parentheses. Those are going to be positive numbers. So we need to find out what the end balance is going to be. Now there's a couple ways to do this. We could start with 5,889 and then add this to it, and then subtract this, and then add this, and then subtract this. But that's going to be a lot of work. I think it's a little more efficient if we add together all the positive numbers, okay, or all our assets, and then add together our negative numbers, our debts, and then just subtract the 2. So that's the way we're going to attack this problem. It's going to save us a couple steps. So let's start with adding together the positives. We'll have 5,889, 927, and then 1,645. We can add them up all together. Okay. We're going to start over on the ones place. 9 plus 7 is 16, plus 5 is 21. Carry the 2. Now we can start adding. 2 plus 8 is 10, plus 2 is 12, plus 4 is 16. So 6, carry the 1. Then we have 1 plus 8 is 9, plus 9 is 18, plus 6 is 24. So that's 4, carry the 2. And then 5 plus 2 is 7, plus 1 is 8. So all our assets are 8,461. And this is going to be a positive number. Remember, those are our assets, so that's going to be positive. not times, but positive. Now let's add together all of our debts. So our debts, there was only two of them. We had 2,928 and 6,321. When we add these together, we get 9, 4, 12, and then 9. Okay, so these are all our debts. Okay, remember that's going to be negative because those are debts, so those are negative numbers. Okay, so now we have to subtract these two. We have 8,461 minus 9,249. Okay, these are different sign numbers. We've got a positive here and a negative here. So we're going to subtract these two numbers and keep the number of the sign of the bigger number. This number has the largest absolute value, so this is what's going to go on top and where we're going to take our sign from. So we'll do that 9,249 minus 8,461. We said the sign was going to be negative, so I'm going to write that in now so I don't forget it later. Then we can start subtracting in the ones place. 9 minus 1 is 8. We can't do 4 minus 6, so we borrow. And we get 14 minus 6, which is 8. We can't do 1 minus 4, so we'll borrow again. And we'll get 11 minus 4, which is 7. And then 8 minus 8 is 0. So our final balance for this is going to be negative $788. Here's a second word problem. This asks us to list the cities in order from largest to smallest range in temperature extremes. Okay, so first we need to know what the definition of a range is, and this is the same for a distance. A range equals the biggest minus the smallest value. Okay, so we're always going to take the big number and then we're going to subtract the smallest number. So let's do that for each of these cities so we can rank them. The first, Atlantic City. To find this range, we're going to do 102 minus negative 3. Okay, we get a double sign. Those are the same, so it should be plus. We'll write this as 102 plus 3, or when we add those together, 105. Okay. Next, for Barrow, Alaska, we have 79 minus the smallest, negative 56. Again, this double sign is going to be a plus, so we'll get 79 plus 56. Then we'll add those two together. Yeah, I believe 135. Next, for Greensboro, North Carolina, 104 minus negative 8. Or when we get rid of the double sign, 104 plus 8, which is 112. For Norfolk, Virginia, 105 minus negative 3. That double sign will change this to 105 plus 3, which is 108. Okay. Last but not least, Portland, Maine, 103 minus negative 39. That double sign is going to become a positive, so 103 plus 39, which is 142. Okay, now that we have all the ranges, we can rank them. The largest seems to be Portland, so that's going to be number 1. Second largest is going to be Barrow, Alaska. And then Greensboro. Then Norfolk. Then Atlantic City. Okay, so keep in mind, whenever you're asked to find a range, you're going to do the biggest number minus the smallest number. And as we saw, sometimes we're going to get a lot of double negatives in here, and that'll end up being an addition problem. So don't let you throw that off. That makes sense that if the high is 102, then the range, if it goes to a negative number, should be at least more than 102. So don't get confused if your subtraction problem turns into an addition problem. That's definitely okay. So to review for our sections 2 and 3, we covered the double sign rules, then how to add and subtract or combine those integers together. We practiced with both small and large numbers. We did combinations of different operations, long strings of problems. Then we looked at some applications for the text. Then we did some sample word problems as well. Stay tuned for our next set of videos. We're again going to combine sections 4 and 5 because those rules are the same for multiplying and dividing integers.